Hi, welcome back. As you know, I'm Miro, and today I have one project, and the project is about VEVOR gas forge. So that's it. This is VEVOR 3-burner gas forge, which I bought I think 2 years ago. I'm using it not quite often because I prefer my classic coal forge, but if I need to heat something long for quenching, or it's just a long material which I need to heat in one piece, and I use this forge. For start, I bought this forge for my own money, so it's not sponsored, but I use it. I bought it from VEVOR, so that's it. This forge functions quite well, but there is a few issues which I finally have time to sort. As you noticed, the one burner is out and it's dismantled, and this is because those hoses. In those hoses you have your propane, and the one main disadvantage of this forge is the rising heat. So the rising heat is causing that those hoses are going soft, and those hose clamps are not strong enough to hold the pressure of the gas, and when the line is soft, the line will just pop out, and gas is hissing all over the place. And last time I use this first burner, hose pop up, and the gas went straight down and it catch fire. Luckily I was not near the forge, so I very quickly managed to put the flame out, and nobody was hurt. So first thing what I need to do is to sort these things. So I think about solid lines, so I will use those copper pipes. They are used for heating or for water, and they are soft soldered. Soft solder has melting temperature around 230-240 degrees of Celsius, so there is not enough heat to melt this soft solder, so it will be safe. So as you can see, there is the mock-up how this will be in the final state. So 3 rising tubes from the side to the top, and there is the main valve, there is the jet, and the main feed for the gas is there, and the main feed will be maybe back or there, just don't know how those things will do. Second thing, and this is major thing, this is minor thing, is this collet. with this collet you can adjust the amount of the air which is mixing with the gas, and those screws, especially when when you're wearing gloves, it's not big enough. So this is another thing, so I need to make something a little bigger. And the next thing is, if you loosen the screw enough, the collet will just fall down. There is a little recess, I hope you can see it, and if not, so there is a little recess where the bolt sliding. So I want to adjust it a little bit, so I will weld something down there so it will not fall down completely. Next thing is about inner temperature, because this forge, as you can see, is just straight through. There is no doors in the back, and none from the front. So I will fabricate some type of doors so you can close it up and raise the inner temperature much higher. And the last thing, and a few things, I will not explain it all because I'm talking too much. I will fabricate some sort of stand where I can accommodate my gas tank and move the forge around the shop. So after some problems, I managed to get those things out. First was without problem, second without problem, but in the third, the fitting just snapped. So, oh, you know. So next in the line is this. 1, 2, and 3. And originally there was thread sealant. It's not good to use thread sealant because thread sealant under heat just softens and loses all the properties, and it's not meant to use the thread lock as a sealant. So I will use this Teflon thread. So it's done, and now just screw this inside. The tip of the jet should be somewhere around 1/3 of the space. It could be even around 1/2. The way how deep this jet is inside is affecting how much air will be sucked in, so it later affect your flame. So I have it around a half, and I will put it a little bit back and snug the lock nut, and it's done. Again, repeat 3 times, and then I can put this flange for now without seal and orient it the right way. So I have it roughly in place, and now it's time decide where I will have the main bus, or how could I call it, for the gas to go in. So I will put it roughly there, so I have space below for the another things which I want to do with this forge. So for this I need to assemble the rail from several pieces. So this is main input. It's from 10 millimeter hose barb to 3¼ to 22 millimeter. So this will go there. Then some pipe. This is not the right dimension, but for the illustration it will be fine. This will be reduced from 22 to 18, and finally we need reduction for the last pipe to 15 millimeters. So I will roughly put it in there, so we have some centers. So this is go there, this will go there, and this will go there. Reduction. So now I can cut my pipes and mock it together. For now, without soldering, just for the dry fit. Pipes are cut, and we are perfectly in the middle of each burner. So now I need to prepare for the soldering, so clean them up, and for the soldering I'm using this paste. It's I don't know, there is a lead and silver, tin, and cuprum, alias copper. The main bus is done, so now I will set this into the height which will be fine, and then I can measure the distance between the rail and the top of the pipe which leads from the burner. I will use this angle and I will measure distance to the bottom. So for me it's 47. It's like wrong. 49, 46, and 43. So reduction by 3 centimeters. 49, 46, 43. I will write it down so I will not forget. Next measurement which I need is for those pipes, and it's not too difficult to measure because I know the diameter, and then I can measure from the middle of the burner to the middle approximately of this tube, so it will be always 11 centimeters. My pipes are in the place, and now I will measure the final destination. Now the roller movie. My initial measurement was quite success, so I will cut the final tubes, then again clean all the joints, and it's ready to final soldering. And there it is. It took me about 2 hours to finish it to the state, included the time when I must reposition camera and so on. So nothing difficult. It looks quite nice. So for me there is the back of the forge, so I have everything nice and in the reach. Screw for the positioning of the collets, valves for the gas, and the main is there. I will make probably some kind of collet or something which will hold this tube in the place, so it will not wobble, but as you can see it's not wobbling, just a little bit flex. So it's done. Don't forget to put fiber gaskets, not rubber, because the heat can disintegrate the rubber seal, and it will not seal anymore. The forge is finished. I intentionally didn't record welding of the card because I think it's very simple and everyone can adjust card for itself. So the main features which I mentioned on the start of this video, and main concern was the floppy pipes. Now it's remanufactured in the copper, so it's very rigid. If you need to dismantle all of this, you just take it out and disconnect from the gas line, and you can go. Also, if you need to disassemble the forge, you just pick it up. So as you can see, this is all set up. I made two doors. One door is fully covering the back of the forge, and the front door are with this little gap, so you can insert your workpiece in there, and if you have a handle such this, just put it in and still you have plenty of room. There is a handle, so you can grab it and move it wherever you want. And I also added this little thing, so if you have a big material or a long handle, it will not fall out if you are in the forward part of the forge. So final thing is to get it started, so you can see the final product. So this is on the full blast from the first burner. Now I will engage the second one and the third one. You can see that is nice and hot, and main advantage of the door is that the heat will not escape from the back. So I will wrap this video because it's done. So that was a little bit of upgrade the VEVOR forge. I think this will serve me for a long time. It will come So that's all. I hope you enjoyed this video. Please subscribe, like, and if you want to tell something which I can do better, just leave me a comment. Thank you very much for watching, and see you later.